In this video, we're going to look at our last two examples of how to solve rational equations. Remember, the first thing we want to do is we want to find our excluded values. So I have 5 over x squared minus 1 plus 3x minus 2 over x minus 1 equals 3x plus 2 over x plus 1. The first thing that should stand out is that this denominator x squared minus 1 is not factored. I will have to factor that so I can see all of my excluded values. So x squared minus 1 is a difference of squares. Factoring it gives me x plus 1, x minus 1. So now if I want to state my excluded values, I see in the denominator I have an x plus 1. So set that equal to 0, you get x equals -1. And I have an x minus 1. Set that equal to 0, and I get x equals +1. So my excluded values are positive or -1. Now I need to find my common denominator. Your common denominator here, you see this denominator has an x plus 1 and an x minus 1 in it. This just has an x minus 1, and this just has an x plus 1. So my common denominator here is going to be x plus 1, x minus 1. And so that's what I'm going to multiply the entire equation by. So let's take this equation, I'm going to move it down here, and I'm going to multiply the left side and the right side of the equation by my common denominator. I'm going to multiply it by x plus 1 and x minus 1. All right, so if I do that, I'm going to distribute it to both terms on the left side. So if I do it to the first term, remember, x squared minus 1 factors into x plus 1 and x minus 1. So when I distribute this to the first term, I'm going to have an x plus 1 at the top and 1 at the bottom, so they're going to cancel. I'm also going to have an x minus 1 at the top and an x minus 1 at the bottom. So all I'm left with is just 5. Plus, and when I distribute to the second term, I'm going to have an x minus 1 in the top and an x minus 1 at the bottom. So those will cancel. So the expression 3x minus 2 is only going to be multiplied by the x plus 1. And on the right side, when I distribute, the x plus 1 is in the top and the bottom. So my 3x plus 2 is going to be multiplied by x minus 1. And so now what I'm going to do is distribute, simplify, and then go about solving. So this 5, that's easy, just drop it down. When I distribute here, I'm going to get 3x squared plus 3x minus 2x minus 2. Combine like terms there, you get plus 3x squared. 3x and -2x is positive x minus 2. And same thing, if I distribute here, I'm going to get 3x squared minus 3x plus 2x minus 2. Combine the like terms, you're going to get 3x squared minus x minus 2. And so now I'm going to go through and simplify. I notice right off the bat I have a 3x squared on the left side and a 3x squared on the right side, so those can cancel. I can also see I have a -2 on the left and a -2 on the right. They have to be exactly the same for me to cancel. So really, I'm left with 5 plus x equals -x. Well, to solve here, what I'm going to do is move this -x to the other side by adding it, which gives me 2x. and then I would subtract the 5, so 2x equals negative 5. Divide both sides by 2, x is negative 5 halves. My excluded values were x equals negative 1 and x equals positive 1, which negative 5 halves is not equivalent to those, so therefore I can consider that my answer for this. So this one involved some work when it came to distributing and combined like terms, so just be careful with the small mathematical calculations for mistakes. Let's look at number 7, our last one for solving. First thing we have to do is find our excluded values. So your excluded values are where your denominator equals 0. Right off the bat, I can see this x squared plus 8x plus 15 needs factored. So to factor this, I need two numbers that multiply to give me 15 and add to give me 8. And that's positive 5 and positive 3. So x plus 5, x plus 3 is the factored form of this denominator. So my excluded values are where my denominators equal 0. So first, I'm going to set x plus 5 equal to 0. That's going to give me negative 5. I'm going to set x plus 3 equal to 0. And that's going to give me negative 3. I have an x plus 5 here and an x plus 3. Those are already accounted for. So these are my excluded values. I cannot have a solution that's negative 5 or negative 3. Next step is to find your common denominator. Well, if I take a look, this has the x plus 5. This has an x plus 5. This is missing it. So I know it's needed over here. So I'm going to put that down. This has an x plus 3. This has an x plus 3. This is missing it. And if I look at it, remember for common denominators, they all have to have the same exact expression. Well, this has both x plus 5 and x plus 3. So I just need to put the x plus 3 here, the x plus 5 here, and I'm going to get a common denominator. So this is what I'm going to multiply both sides of the rational equation by. So let me grab it to give myself some room to perform my multiplication. I'm going to multiply the left side and the right side by x plus 5 and x plus 3. So x plus 5 and x plus 3. As I mentioned before, you notice how I write it small and it looks like in part of the numerator. And the reason why is that helps me see the canceling out without showing all of my work. It also allows me to know this is only technically being multiplied to the numerator, not the denominator. And so when I distribute to the first fraction, I'm going to have an x plus 5 at the top and the bottom. So this 2x is only going to be multiplied by the x plus 3. If I distribute to the second term, I have minus. I have an x plus 5 in the top and the bottom. They're going to cancel. I have an x plus 3 in the top and the bottom. So the whole denominator is going to cancel here. So I'm subtracting this entire expression. And this is where you need to start getting in Algebra 2 is this is an expression. So technically it's grouped together. So when you are subtracting, you need to put it in parentheses. And when I distribute on the right side, I have an x plus 3 in the bottom and an x plus 3 in the top. So this 3 is only going to be multiplied by x plus 5. And so my job now is to distribute, combine like terms, simplify, and then solve. So I'm going to get 2x squared plus 6x. When you distribute the minus sign to all of these terms, it's just going to change their sign. So this is going to be negative x squared plus x plus 10 equals 3x plus 15. So if I simplify this left side first, 2x squared minus x squared, I'm going to get x squared, 6x, and x is 7x. So I get x squared plus 7x plus 10 equals 3x plus 15. Since I have a quadratic in a linear term, I'm going to set it equal to 0, factor, and solve. So I would subtract the 3x and I would subtract 15 to give me x squared plus 4x minus 5. And to factor this, you want two numbers that multiply to give you -5 and add to give you a positive 4. Well, that's x plus 5 and x minus 1. So to solve, set each one of these equal to 0. X plus 5 equals 0. X is -5. X minus 1 equals 0. X is 1. However, we need to remember to check for our excluded values. So if I scroll up for this and take a look, my excluded values are -5 and -3. Well, one of my answers is -5, and that's not possible because if I were to have a -5, I would get a 0 in the denominator here and here, and you cannot divide by 0. So this is not a solution. The only solution I have here then is x equals 1. And so in this example, we see the reason why we have to always write down our excluded values, because if we get an answer that is one of those, we have to cross it out because it's not possible. Our vertical asymptotes exist there, so a point can't exist there. And you're left with just what remains. So I hope you found this video helpful on how to solve rational equations. Remember, first thing you do is find your excluded values, look at your common denominator, multiply through by the common denominator, simplify and solve, and check your excluded values to make sure the answers are correct.